Hi students, this is Mr. Ivan, and today we're going to talk about speed time graph and one important concept of speed time graph, which is conversion of the speed time graph to distance time graph. Alright, so for concepts number one, speed time graph is the most commonly given graph and tested in E-Math papers. Okay, so number one, remember that the gradient of the speed time graph of speed time will give you equals to the acceleration. Okay, if acceleration, if the gradient is positive, all right, and also equals to the deceleration, okay, if the gradient is negative, or another word for deceleration is retardation. Okay, gradient of speed time graph is equals to acceleration or deceleration. Next, number two, to find the distance, okay, it is the area under graph. All right, and number three, if you have a straight line in the speed time graph, okay, this means that when you have straight line, it means constant speed, and when you hear constant speed, it means acceleration is equals to 0. There's a 0 acceleration in this way. So if you look at the graph, where is the part that you will have 0 acceleration? It will be here, 0 meter per second square. 0 acceleration. Alright, so these are three concepts. Now in terms of solving, there are two major major ways they can ask you and students struggle in, okay, which is number one. Alright, so you read the question. This is the speed time graph of the car's journey in the first t seconds. Alright, so they want to find the speed of the car when the t is equals to 15. So where is t equals to 15? 15 is probably somewhere around here. Alright, so this is a kind of question where most students struggle. So always remember that when you are between here to here, okay, what is the same? You look at the slope. The whole slope is constant throughout. Alright, so the gradient is the same, and we will use the gradient method to find the speed when t is equals to 15. So when t equals to 15, you will probably be around here. Alright, let's mark out a possible coordinate of here. So they are looking for the speed of the car, which is v. So we will consider this to be 15, v. Alright, so over here, this will be 22, 50. Over here, this will be 12, 20. Alright, so this method is trying to say that the gradient of this and this, okay, is equals to the gradient of this, the coordinate here and here. So this is how we equate them together. And recall that formula for gradient is equals to, so I'll write down here, gradient is equals to y2 minus y1 over x2 minus x1. Okay, so for gradient, let's take the two furthest point, 50 minus 20 over 22 minus 12. Okay, so that's the gradient between this point and this point is equals to v minus 20 over 15 minus 12. Okay, is equals to the same gradient as this point and this point. Alright, so this is how we form the equation. I will have 30 over 10 is equals to v minus 20 over 3. Okay, so 30 over 10 is 3, 3 times 3, 9. So which means I have v minus 20 equals to 9. V is equals to 29 meter per second. Okay, remember to write your units for the question. Okay, so this is how you find an unknown v. Okay, so for next one, B, the car decelerates at 3 meter per second square. So when does the car decelerate? So let's look at this graph. From the first 4 seconds, the speed increases from 0 to 20. So of course, this is accelerating. Okay, so this is accelerating at acceleration greater than 0. From 4th second to 12th second, the speed is constant. Constant speed equals to 0 acceleration. Always remember, constant speed equals to 0 acceleration. Next, from second 12 to second 20, again, speed is going up, means it is accelerating. So when will it be decelerating? This is the part where the vehicle is decelerating. Alright, now Also understand the difference between the gradient and deceleration. Okay, so the car decelerate at 3 meter per second squared. Now in your concept, when did I mention acceleration? It is concept number 1, where I say that the gradient of the speed time graph is equals to either the acceleration or the deceleration. So next, look at your graph. In the from the second number 22 to t, the slope is going down. So what kind of gradient are we having? We are having a negative gradient. Okay, so let's label this. This is t comma 0. All right. So which means that 50 minus 0, y2 minus y1 over 22 minus t, okay, 50 minus 0 over 22 minus t is going to give you, most students will write 3, and that is where the catalyst is, because the question already tell you that it is decelerating at 3. Decelerate, when you have a deceleration, you need to have a negative sign. So there's, and it is 2 different ways of saying, so you can either say that the vehicle is decelerating at 3 meter per second square. Deceleration, you cannot put a negative sign there, but you can also say that the vehicle is acceleration at negative 3 meter per second square. Now when we say that is accelerating at negative 3 meter per second square, it means that it is decelerating. Alright, but when you cannot have negative sign in when you use the word deceleration. Okay, so this is the difference in the 2 words. So you have 50 is equals to negative 3 bracket 22 minus t. 50 is equals to negative 66 plus t. So t would be equals to, okay, so you have a 3t here. So 3t is equals to 116, and then t will be equals to 38.7 seconds. Okay, and so same thing, you realize that we use the gradient way to find many things. Number 1, we can use the gradient to find speed in the first part of the question, when speed is unknown in the middle of the period. Okay, next is we can use gradient again to find t, but because that's also because in this case they tell you that it is decelerating. If the question tells you that the distance traveled for it, then we are going to use area under graph to find it instead. Okay, now then the last one, where we are going to draw the distance time graph, and that is the most important part of the question that most students do not understand how to draw the corresponding graph. Okay, so the question is here again. Now when I have the corresponding graph, all right, one thing about when you are drawing the corresponding graph is you need to know the distance specifically. Okay, even though it says sketch. All right, so I'm breaking up the graph into portion A, portion B, portion C, and portion D. Okay, so for C, the distance traveled for A, okay, is equals to half times 4 times 20. All right, and that will give you 40 meters. Okay, so the distance for B, okay, is equals to the base of this rectangle is 12 minus 4, okay, times the height is 20, all right, and then that you will have 160 meter, okay, and then for the distance for C is equals to, now many students at this point of time, Sec 4 mostly, okay, forget what is the formula for area of trapezium. Okay, it's half times perpendicular height. So where is the perpendicular height? In this case, this is the perpendicular height, which is 10, okay, times A plus B. What is A plus B? Sum of parallel side. Parallel side 1, this is 20. Parallel side 2, this is 50. Okay, and then you will have 550 meters. Okay, and of course you need the distance for D, okay, which is half times, now in this case T is already 38.7, yeah, okay, times 38.7 minus 22, because we need to find out the length of here. All right, and the height is 50, and it would actually give you equals to, okay, 9 0.662 meters. Okay, now since we have some space here, I will draw this distance time graph to be bigger. Okay, so first let's label. Number one, so when I draw the distance time graph, I try to correspond it with the graph that I have on top. Can you see the axes are corresponding? Now the time is 4, 12, 22 followed by 38.7. Alright, next is I have to label the distance. For the first part in A, what is the distance it traveled? It traveled 40 meter. Okay, or rather we do not write meter here, we write here is time per second, here is distance per meter. Okay, next in B it traveled 160, and again this is where careless comes in. Most students will label here 160. Okay, which is wrong. It's not. It's 160 on top of 40, which makes it 200. Alright, and when you go to 22, okay, it would be okay, so this one is my mistake. It should not be 550 over here, 70, so this is 350. Okay, 350, and when you add on top, this will be 550. Okay, and then the last part, alright, this is incorrect as well, so it will be 550 minus this will be 416 2/3, and that will make this to become 966 2/3. Okay, so be very careful over here. I did the working in a different manner. Okay, so this is the part where the car travels in each separate region. Okay, so you have to add the first part, you have to add the first part, you have to add the first part to it. Okay, so for the first part, okay, the important is the translation. Now your car is here, the speed is 0, then it starts to increase speed to 20, which means that at the start, when the car just moves off, does it travel slowly, then it becomes fast? Yes, right. So this is the corresponding graph for fast to slow. Okay, it will take a longer time to travel the same amount of distance, then it starts to pick up. So this is from fast to slow. Sorry, it's from slow to fast. Okay, next, constant speed. Constant speed means the distance increases constantly, so it will go to here. Okay, and then next, again, the speed is increasing from 20 to 50, so it would go in this manner. Alright, but in this case it's not as steep as the first part, because can you see that the gradient for the second part is more gentle than the first part, so it feels like a more gentle. And then the third part, when it decelerates, okay, and it decreases speed from 50 all the way to 0. Okay, so so this portion is from slow to fast, is always in this shape. Okay, now the next portion is from fast to slow. Now even when you are slowing down, is your distance increasing? Is also increasing, so it would look like this. Okay, so this one, try to correspond it with the axis over here, and then important, you must know that this portion is when you are going from fast to slow. Okay, so this is a part where students always struggle transferring the speed time graph to distance time graph, not just in math, and it's also in physics. Okay, so remember the two things. Fast to slow is a curve going upwards. Okay, this is fast to slow, this is fast to slow, and sorry, this is slow to fast, and this is slow to fast, and the last part is where this is fast to slow. Okay, it will travel more distance in a shorter time, and then it gradually slows down. Okay, and this covers the two kind of hardest question in speed time graph.